How's it going, everyone? This video will go over percentiles and what they are, how to calculate them, okay, what they mean. So percentiles looks at what percentage of a set of data is below a certain value. So this could be with health or with sports, right? Scores in different games, marks, anywhere where you're interested in knowing what percentage of the population is expected to have below a certain value. For example, if your height is in the 90th percentile, that means 90% of the population is expected to be shorter than you, right? If your score is in the 60th percentile, it means 60% of the population is expected to have a lower score than you. It doesn't mean that your score is actually 60%. Okay, so let's have an example, right? Let's say your data, let's say this is scores in some game, okay, and it looks like this. Okay, so let's say you can score between 1 and 10, and a certain number of people played it. We have 1, 2, 3, 4, 5, 6, 7, 8, 9 people, right? So sample size equals 9, right? And I put the data points in order here already, and that's going to become useful because when you're calculating percentiles, you want to look at the data points in order because you're going to have to find the rank, as in like the first data point, the second data point, the third data point, and so on, from smallest to largest. You're going to calculate that to calculate percentiles. So let's say you want to find the 80th percentile. Okay, what that means is find the value such that 80% of the data is below that value. Okay, and here's how you do that. First, you look for that rank. Okay, and the rank is going to be equal to n plus 1, where n is your number of data points, times the percentile you're looking for divided by 100. So in our case, our sample size is 9, right? So it's going to be 9 plus 1 times 80 over 100, which comes to 10 times 0.8, or 8. Okay, so the rank of our percentile is 8. So we look for the 8th data point if they're arranged from smallest to largest. 1, 2, 3, 4, 5, 6, 7, 8. Okay, and our data point happens to be equal to an 8. Okay, so 8 is our 80th percentile. Okay, now let's say we want to find the 60th percentile. Okay, so find 60th percentile. All right, so again, we start by looking for our rank. So 1 plus 9, that's our number of data points, times 60 over 100, that's going to be 10 times 0.6, or just 6. So we look for the 6th rank, right? 1, 2, 3, 4, 5, 6, and that happens to be a 7. Okay, so our 60th percentile is 7, right? 60% of the population is expected to score below 7, right? Or 80% of the population is expected to score below 8. So it's important to understand the rank and the percentile are different things, right? The rank tells you where to find the percentile as you move through your data points from smallest to largest. The data point you end off with, that is your actual percentile. Okay? Now, it doesn't always turn out to be so clean in terms of whole numbers. Let's say our data looks like this. Let's say we have 150, 152, 161, 165, 172, 180, 185, and 190. as our data points. Okay, so our sample size is 1, 2, 3, 4, 5, 6, 7, 8. Okay, and we want to find the 67th percentile. Okay, so that's 2/3. 2/3 of the data being below a certain value. Okay, so we look for our rank, which is going to be 1 plus n times p over 100. And that comes to 8 plus 1 times 67 over 100, which comes to 9 times 0.67. Okay, and 9 times 0.67 gives us 6.03. Okay, so that's not a whole number, right? Now, there's different ways of dealing with that, right? In some applications, you might be told always round up. So we just treat that like a rank of 7. And some applications will say round appropriately. Well, so that should round to a 6, so you treat it like a rank of 6. The most precise way of dealing with it is not to round at all. And here's how you do that. Find the 6th data point, 1, 2, 3, 4, 5, 6. That's the 180. Okay, but it's going to be somewhere between 180 and 185, which is our 7th data point, right? Because 6.03 is somewhere between 6 and 7. So our percentile is going to be 180 plus something. And what's the something? Well, it's going to be 0.03, right? 0.03 of the path between the 7th data point and the 6th data point. 185 minus 180. That's the gap between the 6th and 7th data point. So whatever our decimal is, 0.03, of that gap, that's what we have to add on, right? So that's going to be 180 plus 0.03 times, in this case, 5, right? Because in this case, our gap happens to be 5 between 180 and 185. So what we get is 180 plus 0.03 times 5 is 0.15, right? And so that gives us 180.15. Okay, that, not 180, not 185, but 180.15, that is our 67th percentile. Okay. So you can expect 67%, or 2/3 of the data, to be below 180.15, right? That's how percentiles work in those kind of decimal situations. And there are certain terms used for specific percentiles. So the 25th percentile is also known as the first quartile. Okay, the 75th percentile is known as the third quartile, right? Because 25 percentile, that means 1/4 of the data is below that value. 75th percentile is the value such that 3/4 of the data is below that value. And the 50th percentile is the second quartile, right? And it's also known as the median. Okay, the median data point is the 50th percentile, right? And for our example here, if we wanted to find that 50th percentile, we would do n plus 1 times 50 over 100, right? So we would have, our n is 8, right, in this case. So we would have 8 plus 1 times 0.5, right? Or 9 times 0.5, which would give us 4.5. And that is our rank. Okay, so we look at our data points, 1, 2, 3, 4. That's the 4th data point. So it would be somewhere between the 4th and the 5th data point, right? So it would be 165 plus something, right? 165 plus the decimal point is the 0.5, right? 0.5 of the path between the 4th data point and the 5th data point. So what is that? 172 minus 165. 172 minus 165, right? So that's 165 plus 0.5, and the difference there will be 7. Right, so that's going to be 165 plus 3.5, which is going to be 168.5. That is our 50th percentile. That's also our 2nd quartile, and it's also the median, right? If we were just asked to calculate the median of this data set, well, we would cancel out numbers, pairs from smallest to largest, until we're left with either 1 or 2 at the end, and we're left with 2 at the end, right? And when you want to calculate the median and you have 2 numbers in the middle, you take the average of them. 165 plus 172 divided by 2. Right? And if we calculate that, 165 plus 172 divided by 2, right? That gives us 337 divided by 2, and that will give us, no surprises, 168.5. So that's percentiles and how to calculate them. So I'll see you next time.